Yes. Yeah. Come to the another session of the probability and statistics. So here, let me start with the some of the properties of expectation as well as the variances. So let me take the properties of expectation or mean. So let me start with the first property. If capital X is a random variable and is A is constant, then expectation of a constant into random variable X is A into expectation of X. This is what the thing. So if you take an example, expectation of 5 into X is 5 into expectation of X. You have to write it as whatever the value you are getting, that you need to write it as. So then similarly, if X and Y are the random variables, expectation of X plus Y is expectation of X plus expectation of Y, and the other one is expectation of X minus Y is equivalent to expectation of X minus expectation of Y. Right. Next one, again, if X and Y are the random variables, expectation of X into Y is a multiplication, which I can represent as a similarly a conditional probability. Expectation of X into expectation of Y given X, and other you can represent as what? Expectation of Y into expectation of X given Y. These we will call it as what? That you know that this will be what ma? The conditional probability, same as it is of your the multiplication property. Sorry, conditional expectation here you are representing. So this is conditional expectation. Okay. Yeah. That is how you people have to concentrate. Then one more will be if X and Y are independent random variables. If X and Y are the independent random variables. So earlier is the dependent random variable. In that case, E of X, Y is, this you know that the probability of A intersection B, so that I can represent as what? E of X into E of Y I can represent it as. This is that part. Clear? Yeah. Next. Fifth one. If Y is equivalent to AX plus B, where X and Y are random variables and A and B are constants, right? So now if I apply the expectation of this one, expectation of Y is equivalent to expectation of AX plus B here. This you know that expectation of A into X, here I have to represent it as expectation of AX plus expectation of B, where expectation of B is your constant. This you know that the way of writing this one. So A into expectation of X plus B here. So here you people have to observe what is the thing is, this you already written, but the expectation of constant is same as this of the constant. That point you have to keep in your mind. So from this you can take the another point which is called as, that is expectation of constant. Expectation of constant is equivalent to what ma? The constant only, right? Yeah. Next, another point here, if the probability density function is symmetric with respect to a point along the x-axis, then the expectation is equal to the symmetry point. So write down that, I'll give you the clarity. If the probability density function is symmetric with respect to symmetric with respect to a point along x-axis, then the expectation is equivalent to the expectation or mean, which is also called as average value also. Average value is equal to the symmetry point, is equal to the symmetry point. Okay, so let me take an example. Suppose if I have a probability density function like this. Suppose if I am taking the probability density function which is f of x, this value will be this one, which is 5 and 10 more. This is x. Yeah. So for this you need to calculate the expectation actually. So what is the usual process, ma? What is the usual process here? By seeing it is nothing but what? It's a uniform density function. So this value will be 1 by 10 minus 5, which gives you what? 1 by 5 will be there. So here this value is constant. So your f of x is this one. If you want to calculate e of x, so e of x will be what? From 5 to 10, what? Your f of x, which is what? 1 by 5 into dx. So which is nothing but what? 1 by 5 is a constant, and x will be the integration from 5 to 10. You people will have it as. Am I correct or not? So what you are having here? Sorry, ma. Expectation is nothing but what? X, f of x into, actually the definition is what? E of x is equivalent to integral minus infinity to plus infinity x into f of x, na? X into f of x dx. So here 1 by 5 is a constant. This is your f of x. X you have to multiply it as. So this is what? X square by 2 will be there. So that is 1 by 2 will be happening there. Then again you will have it as what? 100 minus 25. So if you are calculating 75 by 75 by 10, which is what? 75. This is the expectation value. This is the process you have to do it as. Am I right or not? That is the process you people have to do it as. Am I right or not? By using this property, what it is, by observing here, see the given density function, probability density function, whatever the density function they had given, that is, if you are observing along the x-axis with respect to a point, see from 5 to 10, in between the point will be what? 7.5 will be there. So this is, see if you check it out with respect to this is symmetry with respect to what? X-axis, na? That directly I can take it as what? Your mean value or not. That is what the point they are mentioning here. Am I right or not? So where the given probability density function is symmetric with respect to a point along the x-axis, then the thing. Then you can take one more example. Then suppose if I take the example like this, my density function will be like this. This is my density function, which is x. This is my f of x. My density function is like this. Yeah, this is 0. Can you tell me what is the expectation of this one? E of x. What is this? Can you tell me? Yeah, the given f of x is symmetric with respect to what? Origin, that is 0, along x-axis. So your e of x will be what? That particular point, which is nothing but what? Your expectation is nothing but what? 0. Likewise, you people have to calculate the problems. That is what directly you can do it as. Getting what I'm saying? No need to calculate it as. No need to calculate. So directly you can observe that point. Getting what I'm saying? So that is how you need to concentrate more. So these are the properties of your mean or expectation. Now let me go with the properties of variance. Properties of variance. Yeah, same thing. If x is a random variable and a is constant, x is random variable and a is constant, then variable of ax, constant into x. Earlier expectation is a into expectation of x, but here the variance will be what? a square into variance of x, a square into variance of x, a square into variance of x. Getting what I'm saying here? A square into variance of x. So let me take an example. Suppose, let me take an example. If I want to calculate variance of minus y here, a value is minus 1, so minus 1 whole square into variance of y it will be. So which is nothing but what again? Minus 1 square plus, you know that. So we will have it as what? Variance of y. So variance is always positive. So variance is always positive. Variance is always positive, right? Yeah. Next point. If x and y are independent random variables, if x and y are the independent random variables, if x and y are the independent random variables, then variance of x plus y is variance of x plus variance of y. Then what about this variance of x minus y? Because variance is always positive, so cannot able to write down variance of x minus variance of y. This I need to represent it as variance of x what plus variance of minus y. So again, you know that what is your variance of minus y from the first resultant? First resultant variance of minus y is what variance of y. Am I correct or not? So that is that particular part. So that just try to substitute it as. So what you will get it as, if I substitute that, I will have here what? So variance of x plus variance of y. This you have to keep in your mind. Both variance of x plus y is variance of x plus variance of y. Variance of x minus y is also variance of x plus variance of y only. Okay, don't get confused. Clear with my point? Yeah. Next point. If a and b are the constants, similar to your earlier case, a and b are constants, x and y are independent random variables. X and y are independent random variables. So that is variance of x minus by. I can represent it as minus. It will be happens plus only So directly I am representing here. For variance, you will have it as what? A square. So that is a square into variance of x plus b square into variance of y. I can mention here. That you keep in your mind. Don't get confused. Okay, that is important, right? Yeah. Next, similarly again in this, one more also you can take it as, that is not a big deal, variance of x by a minus y by b. Can you tell me how I can able to represent as variance of x by a? Means I will go with what 1 by a square into variance of x plus 1 by b square into variance of y. I can mention. Am I right or not? Sure. That is also the criteria. Next, if y is equivalent to ax plus b, where you know that what a and b are constants, x and y are random variables. Yeah, y is equal to x plus b, where a and b are the constants, x and y are the random variables. So if I apply the variance of y is equivalent to variance of ax plus b, right? This I can represent as what variance of ax plus variance of b. This you know that, which is a square into variance of x plus 0. This gives you a square into variance of x. So here you have to keep in your mind the point as what expectation of constant, you written it as what constant, but variance of constant is what? Variance of constant is what 0. So that is variance of a constant. You can make this as 0, right? Yeah. Next point. If x and y are the random variables, if x and y are the random variables, then variance of x plus y. Earlier we written the second point as variance of x plus y for independent random variables. For independent random variables. So directly I represented it as what? Directly I represented what ma? Variance of x plus y is equal to variance of x plus variance of y I written. But this case is what? Here I did not mention you, it is not a independent. So if it is not independent means what ma? Dependent. So for such type of criteria, variance of x plus y is equal to variance of x plus variance of y plus 2 into covariance 2 into covariance of x comma y. I will define you the covariance, don't get bother. Similarly x minus y, variance of x minus y is variance of x plus a variance of y minus 2 into covariance of x comma y. This is the thing. For independent events, this is nothing but what? For independent events, that is what ma? Here covariance. So that the part what you have to keep in your mind is covariance of x comma y is defined as covariance of x comma y is equivalent to expectation of x into y minus expectation of x into expectation of y. This is the definition of the covariance actually. So for independent events, that you know that why you don't get the covariance means for independent events this expectation of x into y will be expectation of x again expectation of y. The two will get cancelled, it will become 0. So that is the reason why in the second point you don't have that particular the covariance thing. So let me take some examples for understanding the concept of your covariances. Can you give me the values? What is the covariance of x comma x and covariance of some a comma b? This is constants. And some covariance of a constant if I have it as. Can you give me these values here? Yeah, you know covariance is what? My expectation of x into y minus expectation of x into expectation of y. So here actually I asked you, this is expectation of, that is covariance of x comma x. Yeah, so what I'll get as here? Expectation of x into expectation of x minus expectation of x into expectation of x. So what I'll have here? What I'll get as here? Sorry, here I done a mistake. Yeah, expectation of x into x. So what I'll get it as? Expectation of, which is nothing but what? This I can represent as what? Expectation of x square minus expectation of x whole square, which is nothing but what? This you know that what? Mean square value minus mean whole square. This directly can I able to write it as what? Variance of x or not? Yes or no? So that is covariance of x comma x will be what ma? Variance of x I can directly represent it as. Then similarly this one, covariance of a comma b, which is nothing but what? Expectation of a into b, that is expectation of constant. What? Constant. Then expectation of a into expectation of b, again ab minus ab, which will become what? 0. Similarly constant, again what? 0. So these are the points what you have to keep in your mind, the part of your what ma? The covariances. Clear with my point? Clear with my point or not? Yeah. And last one more the point ma, it is the small definition actually. Skewness they will ask you. Skewness. Simply they will ask you the skewness. Yeah. That skewness they will give you beta 1 is equivalent to mu 3 square divided by mu 2 cube. Mu 2 cube, where mu 3 is third order central moment or third central moment, and mu 2 is the variance. Actually this is small formula, right? So skewness is the lack of symmetry actually. If I take the note points here, what they will ask you is these based upon these values. If mu1 is equal to 0 in this case, mu3 is equal to 0. Suppose if I take it as the first one, if mu3 is equal to 0, if mu3 is equal to 0, then what will happen? The value of your beta 1, mu3 is equal to 0, beta 1 value will be what? 0. Then the curve is what? symmetry, or also called as what? The curve is skewed. Symmetric itself I will call it as what? The skewness. Am I right or not? Yeah. Then second point, if mu3 is negative, if mu3 is negative, then what will happen? Your beta 1 will be what, ma? If mu3 is negative, then beta 1 will be what? What will happen? Try to understand there. If mu3 is negative, negative means what? This square will be there. Am I correct or not? So mu3 value, that the square value will be there, which is nothing but what? Sorry. Yeah, here this is mu3. That mu3 value I am taking here. This is a negative value. Then what about that beta 1 value? Beta 1 value is also what, ma? Negative. That is not the value of your square here, right? So here the curve we used to call it as what, ma? That curve is negatively skewed. Negatively skewed we will call it as. Negatively skewed, ma. Okay. Then if mu3 is positive, then beta 1 will be positive. Then the curve positively skewed. Positively skewed. Don't get confused. Sir, here the value of this beta 1 is mu3 square, sir. Mu3, if you are doing a mu3, if it is negative, then square will be a positive. Then for positive it will be again what, ma? A positive people will have it as. Am I correct or not? So not like that, ma. That value, just only that mu3 value, that is a third order central movement I am taking here. That third order central movement is negative means, the third order central movement is negative means the curve is negatively skewed. The third order central movement is positive means it is a positively skewed. Clear with my point? That I will give you at the end of the topic also. Don't get bothered, right? So this skewness is for random variable. Again in the statistics part, again we will see the symmetry part. That is this skewness in the statistics also. That is for mean, median, mode. That also we will discuss it as. Don't get confused. Okay. Yeah. So these are the points what you have to keep in your mind with respect to the random variables. Okay, let me start with the problems. Anyhow, I had given examples. Anyhow, I just given you earlier the examples. So based upon that, we'll solve some more problems, ma. We'll solve some more problems. So let me take the problem, that is example or problem, you take it as. Take the problems. Yeah. If x and y are the random variables, if x and y are the random variables, expectation of x is 10, variance of x is 25, find the positive values, of a and b such that y is equivalent to ax minus b has expectation is 0 and variance is 1. This is the question. So you have to take see, x and y are the random variables. Expectation of x they given, variance of x also they had given. You need to calculate the positive values of a and b. You have to calculate the positive values of a and b such that y is equivalent to ax minus b has the expectation is 0 and variance is what, ma? 1. So what are the given values here? Given expectation of x is 10 and variance of x is 25. Similarly, the equation they had given ax minus b here. In this, expectation of y is 0 and variance of y is what, ma? 1 they had given. Am I right or not? Yeah, based upon that they want the values of a and b. So first let me calculate. So take an equation, y is equivalent to ax minus b. So first apply the expectation for this. So what is the expectation of y here? expectation of y is equivalent to expectation of ax minus b. Similarly, on the other hand, calculate the variance. Variance of y is equivalent to variance of ax minus b. So here, this that directly I can represent as a square into expectation of x plus expectation of b, that is a constant. Expectation of constant is what? Expectation of constant. Here a square into variance of x. Expectation of variance of constant is 0. So substitute these values. Expectation of y is what, ma? Expectation of y is what? Sorry. Yeah. Expectation of y is what? Yeah, correct only. Expectation of y is how much? Expectation of y is 0. A square. Expectation of x is what, ma? 10. And plus b will be there. Am I right or not? I think somewhere we are doing some mistake here. I think so. Yeah. Here this is a wrong number. Somewhere we are done mistake. See, expectation means a into that value only. Na, yeah. Yeah. This is what the thing. Y is equivalent to x minus b. Expectation means a into this one only. Am I right or not? Yeah, that is a mistake here. So that is, you will have your what? And this is also mistake. This is expectation we are doing. This is minus. Sorry. This is minus you are doing. So hence from this you will have it as what? B is equivalent to 10 into a. This is an equation. Then similarly go with this calculation, ma. Yeah. What is this? Variance of y is what? Variance of y is what, ma? Variance of y is 1, and this a square into variance of x is what? 25. So from this, a square is equivalent to 1 divided by 25. A is equivalent to plus or minus 1 by 5 will be there, but they asked you what, ma? The positive values. So because it is a positive value, so hence a value will be what? 1 by 5. A is 1 by 5. Then if I substitute that a in this, you will have it as what? B value is equivalent to 10 into 1 by 5, which is how much, ma? 2. So B is, am I right or not? So finally, the positive values of A and B, A is 1 by 5 and B is 2. So this is the positive values of A and B. Am I correct? Am I correct or not? Yeah, that is how you people have to solve the problems regarding this. Yeah, some more additional problems we will do it as. Let me take the next gate problem. Okay, which is a gate problem only. Capital X and Y are two independent random variables. Capital X and Y are two independent random variables with variances 1 and 2 respectively. With the variances 1 and 2 respectively. Let capital Z is equivalent to x minus y. Let capital X is equivalent, capital Z is equivalent to x minus y. Then the variance of capital Z is. Then the variance of capital Z is. Then the variance of capital Z is. This is the question. Yeah. See, in the problem itself they mentioned you here, x and y are the two independent random variables. X and y are the two independent random variables with variances 1 and 2. Means variance of x is 1 and variance of y is 2 respectively. Let they had given z is equivalent to x minus y. let z is equal to x minus y they had given. Then they are asking what the variance of z. So apply variance of z. Variance of z is equal to what ma? Variance of x minus y. This you know that variance is always positive. So variance of x plus a variance of y you people are having. So which is nothing but what ma? 1 plus 2. The answer for this is what? 3. Which is a simple thing or not? The answer for this question is what? 3. So which is a one of the previous gate question. Okay, getting what I'm saying? Getting what I'm saying here? Yeah. Next, that is how you need to solve it as. Next problem, for the function f of x is equivalent to a plus bx. For the function f of x is equivalent to a plus bx, where 0 is less than or equal to x is less than or equal to 1, to be a valid probability density function, small pdf, to be a valid probability density function, which one of the following statements is correct? Which one of the following statements is correct? Option A is equal to 1, B is equal to 4, B is A is 0.5, B is 1, A is 0, B is 1, D, A is 1, B is minus 1. This is that particular criteria. Okay, yeah. So they given f of x this f of x is nothing but what? F of x is nothing but what? F of x is the density function. Am I right or not? F of x is density function. If it is a valid density function, if it is a valid density function, means what? That I already told you that. So the given function if it is a valid function, means it must be what ma? The area under any probability density function is nothing but what? 1. So that is the thing. So area under, if you want to calculate or if you want to validate the given density function is a valid or not, area under any PDF probability density function is always is equivalent to 1. So that is integral minus infinity to plus infinity, integral minus infinity plus infinity to plus minus infinity to plus infinity, f of x dx is equivalent to what ma? F of x dx is equivalent to 1. So this is the most important. This is the most important part. Am I right or not? Yes or no? This is most important. Am I correct? Yeah. So now that this value is varies from where to where? This is varies from where to where ma? 0 to 1. So let me take if I want to make this as a valid density function, so it is taking what from 0 to 1, my f of x. F of x is what? A plus bx into dx, which is equivalent to what ma? 1. So this is a valid density function. Yeah. So do that integration for that. Yeah, for a into x plus for b x square by 2, limits will be what ma? 0 to 1. That is equivalent to 1 it must satisfies. If I want to make this as a valid density function, this I need to do it as. So substitute the limits, you will get it as what ma? A plus b by 2 is equivalent to 1. This is the relation I got it as. This is the relation I got it. Am I right or not? That is the relation I got it. Okay. Yeah. So here you don't know directly the values. So by you can go with what ma? The option verification. So go for the option verification. Right. So by option verification, that this must satisfy. So by option verification, you will get it as what? A is a 0.5 and B is 1 ma. I think option B is the right answer. Okay. Option B is the right answer. Clear? That is how you people have to solve this thing. See, based upon the probability density function, if they are asking, you people have to keep in your mind any area under any probability density function is always is equivalent to 1 ma. Yeah. Likewise, you have to solve it as. Next problem, a probability density function on the interval, a is given by 1 by x square, 1 by x square, and outside this interval, the value of the function, and outside the interval the value of the function, outside the interval the value of the function is 0. Then the value of a is dash. Then the value of a is dash. This is the question. Then the value of a is dash. Nothing is there again. A PDF on the interval they had given from a to 1 is x1 by x square. So that is my f of x is equivalent to the given 1 by x square, which is from what ma? 0 is less than or equal to x is less than or equal to, sorry, a is less than or equal to x is less than or equal to 1 they had given. So it should be a valid, and it is 0, otherwise. This is what they had given. Am I correct or not? The given function will be what ma? This one. Am I correct? Yeah. So based upon that, it should be a valid density function. So you have to take it as what? That you know that. So it is varies from a to 1. So try to do it as integral a to 1 1 by x square into dx. It should be is equal to 1. So substitute 1 by x square integration, we will have it as what ma? Minus 1 by x. So which is a to 1, that value will be 1. So do that. If you check it properly here, you will have the value of your a is 1 by 2, that is 0.5 is the answer for that. So try to check it out ma. This is a simple calculation. You can do it as that calculation, you can perform it as. Check it out properly. Check it out properly there. Okay. Yeah. So likewise you need to solve the things. Clear? Yeah. Next problem. A random variable capital X has PDF, that is probability density function. F of x is equivalent to a plus bx. 0 is less than x is less than 1, and it is 0 otherwise. Okay. If the expectation of x, that is a of x, is 2 by 3, then probability of x is less than 0.5 is dash. This is the question. It's also some of the variety of this problem ma. Some variety. They given the probability density function ma, and expectation of x also they provided, and they are asking what the probability of x is. Probability of x is what? Less than 0.5 they are asking. So what is the probability of x is less than 5? How you will calculate that one? X is less than 5 means what ma? Yes. What? From 0 to what? That value, particular value 1 by 2, you have to do it as. So take down that. Yeah, what they had given in the problem, they given the probability density function f of x they had given, and expectation of x is 2 by 3 they had given, and they are asking simply probability of x is less than 5 ma. Similar to your density function, x is less than 5 means what? So it starts from what ma? 0 to 1 bit. Up to 1 by 2 you have to calculate as. So this is means from 0 to 1 by 2 you have to calculate as. So if you want to go with that, you need to take it as what ma? You need to calculate the values of your a and b. You have to calculate it as. Am I correct or wrong? Yeah. So from 0 to 1 by 2, that is a 0.5 people have to calculate as. Am I right or not? Yeah. So based upon that, you take it as this one. So the given thing will be expectation of x is 2 by 3, right? So based upon that, directly I'm calculating the expectation for you over this one. So which is 0 to 1 x into f of x. X into f of x is what? A plus bx into dx. That value will be what? 2 by 3. So get that value, check it out, what you will get it as here. So a is a constant I will do the integration. A is constant, and for x you will have it as x square by 2 plus b into x square will be there. For that you will have it as what? X cube by 3 from 0 to 1. Am I right or not? So from 0 to 1, this value will be what? 2 divided by 3. So substitute the limits, you will get it as what? The relation, which is nothing but what? I think so, a by 2 plus b by 3, which is equivalent to 2 by 3. So from this you will have it as 3a plus 2b, which is equivalent to what 4. So this you take it as equation 1. This you take it as a equation 1. So that is an expectation part. Am I right or not? That is a expectation part. Yeah. So this is the equation 1. Then and one more thing, you know that what my area under any probability density function is what? 1, you know that. So try to take that also. That is area under any probability density function, which is minus infinity to plus infinity f of x dx, which is equivalent to what? 1, you know that. So try to apply this also. What you will get it as, this is the given thing is 0 to 1, f of x is what a plus bx. All these things we are doing for getting the value of your what a and b. So once if you are getting the value of your a and b, directly you will have the function f of x. So directly you will do it as the probability. So take this, what you will get it as here, you will have it as what? A plus, that is ax plus bx square. I hope you done this earlier. You will have the resultant is what a plus b by 2. You can cross verify it as, or a plus b by 2, that you can repeat as what? 2a plus b will be there. You simplify it as this is equation 2, you will have it as. Okay, so solve it. Solve the equation 1 and 2. By solving 1 and 2, you will have the values of a is 0 and b is 2. By solving equation 1 and 2, you will have the value of your a is 0 and 2, right? So from this if I write the value of your f of x, which is nothing but what so a plus bx, a is 0, b is 2, so which is 2x, which is 0 is less than, x is less than 1 will be there, and it is 0 otherwise, right? So this is the thing. So now I got the value of my f of x. So now I can calculate easily the probability. So what is that? The probability of that is a probability of x is less than 0.5. So from 0 to 0.5 I am calculating my f of x, which is 2x into that is a dx. So give that value. If you are taking this value, you will have it as what 1 by 4, which is what 0.25 is the answer. You can check it out. You can cross verify the direction, that is the direct integration values. That is how you people have to solve that one. Clear now? Getting what I'm saying? Yes. Yeah. Next one more problem. Likewise, you have to solve it simple questions only. The simple mathematical analysis. That's all. Nothing more than that. Simple mathematical analysis. Yeah. Take down the question. Given that capital X is a random variable in the range, capital X is a random variable in the range 0, infinity with a probability density function e to the power of minus x by 2 divided by k, then the value of k is dash. All the problem we have to relate with respect to the property called as what area under any probability density function is what 1. So that is they given what they had given, probability density function they had given f of x is equivalent to e to the power of minus x by 2 by k is there. This will be happening what 0 is less than or equal to, x is less than or equal to infinity. Am I right or not? This is the thing they had given, and you know area under any probability density function is what 1, you know that. So that is integral minus infinity to plus infinity f of x dx. F of x dx is equal to what, ma? 1, you know that. Am I right or not? Yeah. So now substitute these values. So it is varies from 0 to infinity. It is varies from 0 to infinity. My f of x is what, ma? E to the power of minus x by 2 divided by k will be there into dx, which is equal to 1. I will have it as. Am I right or not? So solve this one. What will have it as? If you are solving this, you will have it as what? 1 divided by k is my constant. Integral 0 to infinity e power minus x by 2 dx is equal to 1 will be there. So do the integration, ma. Integration, you know that, na? Yeah. So what you will have it as? So directly I can take it as a k is equal to this one, ma. K is equal to integral 0 to infinity e to the power of minus x by 2 into dx. I can do it as. So now what will happen? E power minus x by 2 divided by integration minus 1 by 2, limits 0 to infinity will be there. So substitute this, you will have minus 2 e power minus x by 2 from 0 to infinity. E power minus infinity is 0, e power 0 is what, ma? 1. So hence you will have the answer as what? Minus 2 is common, e power minus infinity is 0, e power 0 you will have it as this one. So the value of your k is what? The value of your k is what, ma? 2 you will have it as. This is the answer for that particular problem. This is the answer for that particular thing. Clear? Understanding what I'm saying there? Yeah, that is the part of this criteria. Okay. Yeah. So likewise you need to solve the problems based upon that. Yeah, can you try one more problem based upon this analysis? So many problems they asked you in the previous years, ma, based upon that analysis only. Okay. Yeah. Lifetime of an electric bulb. Lifetime of an electrical bulb is a random variable with a density function f of x is equivalent to kx square, where f of x is equal to kx square, where x is measured in years. If the minimum and maximum lifetimes, minimum and maximum lifetimes of a bulb are, minimum and maximum lifetime of bulbs are 1 and 2 years respectively, 1 and 2 years respectively, then the value of a k is, dash. Then the value of a k is dash. Yeah. Simple question only again. F of x is kx square. X is measured in years. Minimum and maximum lifetimes of bulb are 1 and 2 years. Right. So directly this one. So f of x is equivalent to kx square. 1 is less than or equal to, x is less than or equal to 2, which is the given criteria. Am I correct or not? So directly apply the area under any probability density function is 1. You need to calculate the value of your k. So which is integral 1 to 2 my kx square dx is equivalent to 1. So this is what the thing. So if you solve it, the value of your k, you will have it as what, ma? So you will have it as what, k. If you calculate, you will have k is 3 by 7. So I am giving the integration part for you guys. So do the integration. So it's a simple criteria only. If you solve it, you will have the answer as that. Okay. Clear? Yeah. Then similarly, so likewise you can solve the problems, ma. Okay. Can you try one more problem? Problem based upon this? It is one of the other model. Let capital X be the random variable. Capital X be a random variable with a probability density function. capital X be a random variable with a probability density function, f of x is equivalent to 0.2 with a mod x is less than or equal to 1, 0.1, 1 is less, that is 1 is less than mod x is less than or equal to 4, and it is 0 otherwise. This is the probability density function. This is the probability density function. Then the probability then the probability of 0.5 is less than x is less than 5 is dash they are asking. This is a question again. Yes. Again, how you have to do it as they asked a simple thing. See, simple 0.5 is less than x is less than 5, which is equivalent to what? Integral 0 to 5 f of x dx. Right or not? So 0.5 to 5. If you check it out here again, 0.5 to 1 value will be there, and 1 to 4 other value will be there. So this is the part of that criteria. So check it out. The given function will be what, ma? 0.5 to 1 function will be there, f of x dx, plus 1 to 4 one function will be there, based upon the limits, based upon the given limits. So up to less than or equal to 1 value will be there, 1 to 4 the value will be there, right? So just try to substitute that values. So what you are having here, if I substitute that values, integral 0 to 1, sorry, 0.5 to 1, f of x will be what? 0.2 into dx. Then similarly 1 to 4, that value will be what, ma? 0.1. This is dx. So which is nothing but what? 0.2 is common, and for x you will have 0.5 to 1. Similarly, a 0.1 will be there into x, that is 1 to 4 you people have it as. So if you solve this, if you simplify this, you will have the answer as what, ma? 0.4. Right? So if you simplify this, you will have the answer as that. Okay? Yeah. Then similarly, one more problem. Find the value of lambda. Find the value of lambda such that the function f of x is valid PDF. That is, f of x is equivalent to lambda into x minus 1 into 2 minus x. 1 is less than or equal to x is less than or equal to 2, and it is 0, otherwise. This is the question. So you need to solve, or you need to get the value of your what, ma? Lambda. So again, same strategy, ma. It is from 1 to 2. My f of x is equivalent to, that is f of x dx is equivalent to 1. I have to do it as. So solve it. Solve it and give me the value for that. So what I have to solve, this is integral 1 to 2 lambda into x minus 1 into 2 minus x dx is equivalent to 1. So if you solve, you will have the lambda value as 6. Try to check it out. I'm just giving the value for you guys. Integration I'm just giving to you, ma. Method you know that, right? Next, a continuous random variable. Next problem. A continuous random variable capital X has a PDF. F of x is equivalent to e power minus x. 0 is less than x is less than infinity. 0 is less than x is less than infinity. Then probability of x greater than 1 is, probability of x greater than 1 is option A 0.368, B 0.5, C 0.632, D 1. Same again it is. F of x they had given x greater than 1. So 1 to infinite. That's all. X greater than 1 means what? X greater than 1 means what? The property I given you know, yeah. 1 to infinity. My f of x dx I have to calculate it as. So try to do that. I'll have your what? 1 to infinity. F of x is what? E power minus x dx. Substitute it. e power minus x integration e power minus x by minus 1, yeah, from 1 to infinity. E power minus infinity is 0, am I right or not? So minus of e power minus infinity minus e power minus 1, that is 0, you will have it as minus e power minus 1, which is nothing but what, sorry, this is minus of minus plus, you will have it as 1 by e value. So 1 by e value will be around 0.368, you will have it as, okay, right? Yeah, that is the way you have to solve it as. So this is also a very good example. Take down p x of x is equivalent to m e to the power of minus 2 into mod x plus n e to the power of minus 3 into mod x is the PDF, that is a probability density function for the real random variable, over the entire x-axis, m and n are both positive, real numbers, the equation relation of m and n are option A, m plus 2 by 3 n is equal to 1, option B, 2m plus n by 3 is equal to 1, option C, m plus n is equal to 1, option D, m plus n is equal to 3. This is the question. Don't panic. Question seems to be big, but if you solve this, you will have the easiest answer. If you are doing, you will get the easiest thing. Yeah, they given what ma here. Px of x is nothing but what your probability density function, which is a PDF. Entire x-axis means from minus infinity to plus infinity. Am I right or not? So they are asking what the relation between the equation relation between what m and n. You know what the area under any probability density function is, one that you know that. So that is integral minus infinity to plus infinity px of x dx is equivalent to what ma 1. So this for every problem like that you have to do it. So this is what the thing. So based upon that, do it as, that's all, nothing more. So integral what minus infinity to plus infinity px of x is what ma m e to the power of minus 2 mod x plus n e to the power of minus 3 mod x into dx. So here you should take a careful of what mod x ma. You know that mod x is plus for positive, that is x greater than 0, and minus x for x less than 0. That you have to consider it as. Am I right or not? So just I'm directly writing here. So let me take this one. Minus infinity to 0, m e to the power of minus 2 mod x plus n e to the power of minus 3 mod x into dx plus integral 0 to infinity m e to the power of minus 2 mod x plus n e to the power of minus 3 mod x into dx. This value is equivalent to what ma 1. Yeah, so try to do that. From minus infinity to plus 0, I mean minus infinity to 0 ma, this value will be what mod x, this value will be what minus value will be there, so this is minus x, this is also what minus x. Am I correct or not? Yes or no? Then this will be what ma, then this will be what this is a plus x because it is a positive value, because this is plus x. So just substitute it as, so this minus of minus plus will be there, here minus and plus minus will be there. So just try to take this one. So I'll have here what, declare minus infinity to 0 m e power, directly I'm writing ma m e to the power of 2x plus n e to the power of 3x will be there. For this I need to do the integration. Then similarly that will be happens with what ma minus, so that is m e to the power of minus 2x plus n e to the power of minus 3x into dx will be there. This is equivalent to 1. So now for this I need to do the integration. So do the integration for this. If I do the integration, what I'll get as here m e to the power of 2x by 2 plus n e to the power of 3x divided by 3 from minus infinity to 0, substituting the limits. Then similarly for this also, m e to the power of minus 2x by minus 2 plus n e to the power of minus 3x by minus 3, limits from 0 to infinity, which is equivalent to 1. Yeah, if I substitute those values, if I substitute these values, I'll get it as what? M by 2. Directly I'm substituting the values, or else m by 2 e to the power of 2x from minus infinity to 0 plus n by 3 e to the power of 3x from minus infinity to 0. Next plus m by minus 2 e to the power of minus 2x from 0 to infinity plus m by minus 3 from e to the power of minus 0 to infinity, which is equivalent to 1. So substitute those values, substitute these values. Just mathematical calculation, that's all, nothing more than that. E power minus infinity is 0. So directly I am substituting all those values. N by 3 into 1 minus 0 plus m by minus 2 into 0 minus 1 plus n by minus 3 into 0 minus 1, which is equivalent to 1. So this minus minus plus this also minus minus will have plus 1. So directly I will have it as what? M by 2 plus n by 3 plus m by 2 plus n by 3 is equivalent to what? 1. So 2m by 2 by 2 plus 2n by 3 is equivalent to 1. So this 2 will get cancelled. You will have it as what? M plus 2n by 3 is equivalent to 1. So this is the relation between m and the relation equation between m and n. Am I right or not? So option A is the right answer for that. Clear? Yeah. This is how you people have to solve the problems regarding what, ma? This is how you people have to solve the problems regarding what? The thing with the happens of the random variables. That is the mean as well as your what, ma? Expectation things. Getting what I'm saying here? Getting what I'm saying here? That is how you need to solve the problems. Okay. Yeah, that is how you have to solve the problems in the part of your the random variables, that is mean as well as your expectation and the variances. Okay, so this is about this session. So in the next session, I'll start with the distributions like binomial distribution, Poisson distribution, normal distribution, right? So and the last one more topic called as the correlation as well as regression, and then finally we'll go with the statistics part. Okay, so that ends your probability and statistics. Okay, yeah, fine, thank you. We'll meet in the next session.